Cool, thanks, Derek. Yeah, there's a lot of material to get through. Ziggy says all good, but that's the thumb. Yeah, so it's all of 2024, R1 and R2. So there's been two series of updates, the R1 and R2. There's been a lot of material coming out with both of them, and hours worth of material that I've been asked to condense down into 1 hour. So sadly, I've had to ditch a lot of interesting material. So unfortunately, it can't be all things to all people. I've tried to select stuff that will be relevant to most people, as well as having, juicy things that might spark some ideas or inspiration, or give you ideas for other things to do. So these are some of the topics I'll be covering. General mechanical enhancements, so lots of UI stuff, graphics enhancements, mechanical meshing, a lot of changes in meshing, making life easier, getting better meshes, and getting the job done faster. Resource prediction and AI. So this AI thing is creeping in everywhere. So I'll show you what it's doing there. Some scripting and automation. Lots of changes in composites. Hopefully you composites users will be happy with these because we are ditching ACP post, which I'll explain. Some Aqua updates. There's always updates in Contact. So I'll show you some of those. There are more under the hood things that I won't be able to cover. Adaptive element removal. So this is the smart mesh adaptivity. So there's an interesting update here where we can remove elements for some applications. Structural optimization, that's moving along really quickly. The design life fatigue in mechanical is a great tool that's making life a lot easier for using the encode solver within the mechanical environment. So we're starting to do that a lot in the Leap offices, and it's improving our workflows a lot. So I'll show you some of the improvements there. And then LS-Dyna. So I've got an hour to fit this all in. Don't think I'll be able to get any demos in. So yeah, this goes. So everything is going dark mode these days, so you can switch to dark mode if you like, and a lot of people seem to be doing that. I fear change, so I'm sticking with the classic myself, which you can see on the right, or you can have the light mode in the middle. Yeah, the dark mode seems to be very popular with people. So to access this, when you first fire up, let's say 2024 R2 when you install it, which you will, and then go into mechanical, it will ask you to select a theme, and you can see that option there. But later on, you can change it just by going into Tools Options, which you can see on the right. You have a cursor, brilliant. Yeah, there we go. So you go into Tools Options and then UI Options, and there's an option here to change to dark mode or classic or what have you. Now, one interesting change that's been made is the ability to access the mechanical environment outside of Workbench. So you don't necessarily need to have a Workbench project to use mechanical. And there's lots of reasons for this. Some people just like to be able to use mechanical directly. Some of the automation and scripting, there's reasons for that as well. So in order to be able to use mechanical effectively outside of the Workbench environment, lots of capability has to be added into mechanical. So I'll show you what sort of changes are happening there. You can access it through your Windows. Maybe what I'll do is, here's my cursor gone. Laser pointer, that's much better. Yeah, you access it through the Start menu as usual. And instead of firing up Workbench, you just fire up mechanical. So obviously we have to get our model or our geometry or our mesh into mechanical because we're not using, say, Space Claim or Discovery because we're outside of Workbench now. So now we have this import external data option. So you can import models directly into mechanical. So if you have, say, a CDB model or some other geometry, you can import them, or some other mesh, you can import it directly into mechanical here. And you get the same options here as you would get if you're using external data in the Workbench environment. So if you use the external data in Workbench, you import a mesh file from some other solver or Ansys, and then you get all these options for selecting unit systems, which features you want to import or deactivate, or if you want to do translations and rotations of the mesh, what have you. So you can import a CDB file, So CDB is the Ansys format. So that's done here. Geometry import, add model import, and you can bring it in there. And when you do that, you have your details window down here, and that allows you to select unit systems and activate or deactivate which aspects of the model you want to include. And this will bring in all the loads and boundary conditions and other sorts of features. But as soon as you delete that model import, they'll also be deleted from the tree. So they'll go away automatically. And as well as CDB files, you can bring in Abacus and Elastina files. So if you have an old Abacus model that someone's given you and you want to reuse the mesh for that and build a new Ansys model of that, you can import that directly into mechanical from here, and also Elastina format. There's a few limitations at the moment. It's still early days, so we can only do one import at a time at the moment. So one CDB file, one Abacus file, what have you. So that's going to change soon. And we can't combine a geometry import with one of these other imports. So that'll obviously change as well in the future. So if you do want to do that, you'd need to use the workbench environment, because then you can have your geometry and mesh as one component system in your workbench project, bring that into mechanical, and then you can also have an external data reading in your Abacus file or what have you, and then combine that in your mechanical environment. So you do need workbench for that, but things will change in the next few releases that allow you to do all of that in the mechanical environment. And there's also some enhancements for the Nastran export. So if you want to give someone a Nastran model of your Ansys model, you can just right-click on static structural, export Nastran file, and it'll spit out a Nastran mesh. So a few improvements to the beam element exporting. You can now export a transient analysis to a Nastran model, and orthotropic materials, a few other bits and pieces. So that's gradually being improved to support more and more of the Ansys model features to be included in the Nastran file. And then you can also import fluids results directly. So if you want to take your fluent results and import them directly into your mechanical model, not using Workbench, you do that with the imported load feature here. So you can see fluids results file, brings that in, and there's your file, and that applies your loads directly to, in this case, a steady state thermal analysis. So you can read in these fluent or CFX files directly into mechanical. Now, one other nice option that is sort of in this realm is this ability to activate and deactivate features in your tree for each analysis. So for example, if you have your model set up, you have lots of contacts, joints, materials assigned, all of that, you have your static structural analysis. Now you want to do another static structural analysis that reuses your mesh and everything, but you want to have different contacts or a different material assignment. Normally what you'd have to do is duplicate your model in Workbench and have a completely independent, separate model, because once you change your material assignment, it changes it for all of the static structural, modal, harmonic analyses, whatever you're using in there. This new feature allows you to activate or deactivate loads, boundary conditions, and material assignments, and also contacts for each analysis. So you can see our analyses across here: harmonic, two harmonics, a response spectrum, a random vibration, and here's our joints, for example, and you can switch them on or off for each analysis. So you don't have to duplicate the model completely. You can just add another analysis to the tree and then change the setup. And here's the same with contacts. So you can switch on or off different contacts for each analysis system in your tree. And it's also happening for boundary conditions. So at the moment, it's only supported for bolt pretensions and pressure. So you can see our boundary condition. If you squint or walk right up to the screen, you'll see a boundary conditions folder there. Please don't approach the screen. You can put in your boundary conditions here, and they'll be applied to all of the analyses underneath. So now you can change them up here, and it will change the setup for, say, bolt pretension for all of the subsequent analyses. And it's kind of the reverse of that other feature I was telling you, but that's nice because bolt pretensions can be a bit of a hassle to tweak if you have 20 bolt pretensions. And you've got them operating in multiple analyses. You don't want to have to go through 20 of them in each analysis system. You can just change them up here in the folder, and that carries through to all of the subsequent analyses. There's also this table feature. So this table sits under the materials branch here, and it allows us to define a 2D table. Like, say, for example, if we want to define a pressure that varies by over 2 dimensions, we can populate this table with the dimensions in the X and Y and the pressure values here, and then that can be used downstream in a pressure load, or say a temperature distribution that we're applying. So that would look like this. So we're applying a pressure here, and then we just select the table. So rather than defining by a single curve or a single value of pressure, we can define a table in mechanical and apply that here. And one other nice thing you can do is you can parameterize this. So if you have lots of tables defined for different pressure distributions, you can then parameterize this so that you can select different tables for each design point. So if you want to do a design study where you're selecting different pressure distributions for each design point, you can just parameterize this and it will select different tables for that optimization analysis, for example. This new feature is good for, I suppose, LS-Dyna people especially. It's this body merge feature. So if you've been sticking around with Ansys for a long time, you'd know that if you want to get a nice hexahedral mesh onto a geometry, you would split it up into lots of sweepable bits, make a multi-body part out of it, and then mesh it. But then what you have is lots of parts. And if you export an LS-Dyna input file, like a K file, and open it up in LS Prepost, you'll see for every single one of these bodies, you have a separate part definition, separate material definition, and section definition. And they're all identical, but you have to have a separate one for each one. But now we can do this body merge feature where we just combine them all back into one part. So as far as the solver is concerned, it's one part now. And you can see it's all these parts have disappeared from the tree. All the bodies have disappeared from the tree and have turned into a single part. So we can take advantage of being able to split geometry in, say, discovery, make a multi-body part, get a nice mesh on it, and then recombine them into a single part to make life easier down the track for our analysis setup. A few things in graphic enhancement. We have accelerated graphics. It's beta at the moment and it's only exposed for certain features, but it's creeping into more and more aspects of mechanical. You can access that through Tools, Options, Graphics. And you can set it to program controlled, or you can activate it for different aspects of your model. I'll show you where that comes in. So sometimes it doesn't work or it's not applicable to the thing you're currently looking at. And if that happens, you'll get a warning message telling you that in this case, grid aligned vector display is not supported by accelerated graphics, so you can't use it here. That'll change in the future, but for now, it's not supported there. But you can see the option for accelerated graphics here in this, just above the geometry window in mechanical. We have this drop-down menu for the accelerated graphics. So you can leave it as program controlled or say yes if possible. So if accelerated graphics can be used for a particular thing that you're visualizing, like say your mesh visualization, it'll be switched on. So it will speed up visualization and manipulation of many body loads, visualizing the mesh. So when you have a very fine mesh or a large model, sometimes it can get a bit clunky. So the accelerated graphics really helps there. So you can see here, this is an imported body load, and often imported body loads, visualizing the contour plot for that imported load can get a bit clunky. So the accelerated graphics makes it almost instantaneous and makes visualization a lot easier. Okay, meshing. Lots of changes in meshing. I won't go through all of these because I'll be talking through them one at a time over the next few slides. But lots of things like all this NVH stuff, changes for explicit and TET meshing, hex meshing, basically a bit of everything. So one nice thing is this new paradigm for mesh workflows, specifically for NVH. So, vehicle harshness, vibration stuff, and acoustics. So an acoustics analysis, for example, requires a very specific mesh setup. If we want to do this acoustics analysis of this geometry, we need different layers of different types of elements of different density, and then on the outside you need a perfectly matched layer for absorbing the stress wave to infinity. So all of these things need to be set up, and it's hard to remember. So this mesh workflow steps you through that whole process. So it tells you to fill the holes, wrap the parts, improve the wrap mesh, create the enclosure, and then mesh the volume. Basically takes you through the entire step and automates the process of getting an acoustics appropriate mesh for your acoustics analysis. So this supports internal FEM-based acoustics, external FEM-based acoustics, and also the boundary element method acoustics. I'll be showing you that a little bit later. That's Elastine-based. Some just minor enhancements that make life a bit easier. I like this one. They've switched off the default curvature option for shell meshing. This is with curvature on, and I'm always telling people on support and training, just switch that thing off because it gives you these horrible meshes, and it'll give you a more uniform mesh like that. And then if you want a finer mesh, you can add it yourself. So that's off by default now. So it'll save you precious clicks. There's a new quality worksheet, so you can visualize mesh quality here. And if you want to visualize or see the particular elements of a particular quality level, you can just right-click on one of these qualities, and you can generate, say, a contour plot or a histogram, or isolate the failed elements, or you can create named selections of failed elements or elements that fall within a particular quality range directly from this worksheet. And this feature here, we have a little video to demonstrate it for us, is also really nice for explicit users. It'll show us the minimum edge length. So tiny edges always sneak into our geometry and ruin our mesh. And we have to go through and find them, usually by switching on visualization of vertices or just spending hours zooming around our model to find them. So this will find them for us, and then we can go in and create virtual topology for them or use some other method for healing them and getting a better mesh. So that'll save a bit of time. This is also a nice one, an automatic detection of rib edges. So if we have a fillet like this, and we know this is a high stress region, so we want to have really tight control over our mesh size around this fillet, rather than having to go through and manually select all the edges so we can put edge sizing on them. There's an automatic detection of fillets, of edges that lie on fillets, and then we can automatically add our edge sizing. So it just speeds up that whole process. Also, if we have multiple identical bodies and we just want to copy the mesh from one body to the next, rather than having to apply individual mesh controls for each of them, the process for that has become a lot more robust and intelligent. So there are fewer options here in this details window here, because it's a bit smarter, and you can select one body that already has mesh assigned to it and then apply it to another body, and it will work out most of the details for you. So it just streamlines that process. Hex meshing. So there's a few nice updates here. One of them is just making multi-zone generally a lot smarter. So you have to do less messing around with all the options in the multi-zone mesher. So the multi-zone mesher is great for giving us hex meshes on complex geometry. And if you had something like this and you wanted to generate a hex mesh for it, often what we would do to get control over the mesh topology is we would split the geometry up, or we would imprint on the source and target faces to get the mesh sweeping through the way we want. And that got really clunky because it would have to match perfectly on either side. But now we can just imprint on one side and specify that as the source, and it will carry through to the other side. They call it the many-to-one approach. So it's sweeping the many faces here to the one on the other side, and now we have this really nice mesh that we have a lot of control over, and we spend less time faffing about splitting surfaces on both sides and trying to get them to match. Also with multi-zone, here's a blade, and there's a new option. You'll see it more in the next slide, actually, where we can use the mapped control to get a better quality mesh around these round regions. Like here, for example, here's a face meshing feature that we've applied to these faces here in this multi-zone body. And we can specify if the face is a half circle or a quarter circle, and it will generate like an O-grid mesh or a half O-grid or a quarter as appropriate, rather than the messy mesh that you might get previously. So we don't have to imprint faces or anything like that to get a nice uniform hexahedral mesh. But sometimes you want to switch off that mapped face approach. Like, for example, this sort of body, you mesh it with a mapped face, and you end up with these tiny elements in here, which are no good, especially for explicit analysis. So we can switch it off, and we get this more uniform mesh. It may not look as pretty, but it will solve better. For axisymmetric geometries, quite a few enhancements here. We can have edge biasing along the length of the body to allow us to give us more control over the mesh distribution. So combined with a mapped face mesh, which gives us a nice O-grid mesh there, we can use mesh biasing on the edge to get this uniform mesh through here. So if we slice this open and look inside, the old mesher would give us something like this, and we wouldn't see it unless we peek inside and find out what's going on. You get all these horrible meshing, horrible elements like these guys here. With 2024 R1, you get this mesh, which is much nicer. Also, more support for axisymmetric sweeping. This has always been a bit of a hassle if you had axisymmetric geometries and you wanted to get a nice swept mesh around the central axis. So we have this new option here. Where is it? Algorithm axisymmetric. That box has to move, sorry. Put the box right over the text I actually wanted to highlight. Stupid. Yeah, so it automatically identifies axisymmetric geometries, and it will sweep the axisymmetric mesh around here. So previously we'd have to put in multiple multi-zone meshes and specify sources and targets, or use a sweep approach. And it got a bit sort of tricky to get it to work, but now it's much more robust, and we just use this axisymmetric option and it does the job for us. It also automatically detects thin sweepable bodies. So if we apply multi-zone to this, it will look at it and say, hang on, we don't need a multi-zone mesh, what we need is a thin sweep. So rather than having to change it to a sweep meshing method and choose the thin sweep option, it will work that out for us and makes it a nice thin swept geometry. Again, fewer clicks. And this is a really cool enhancement as well, just because it was a total nightmare to get a helix meshed previously. If you had a helical geometry and you want to sweep a mesh that follows that helix, often you'd need to imprint a path that would follow the helix all the way down, and then that would become the path, the profile that the mesh would follow. And sometimes that wouldn't work, and the mesh would get twisted as it followed the helix down. Now we've got this option here for decomposition type medial axis. It's beta at the moment, but it works, and it will make meshing of these helical bodies much easier, get a much better quality mesh. Okay, TET meshing. Patch conforming mesh, some new smarts in here to detect thin regions, so we can have multiple TET elements through the thickness. I'm going to have to speed up a little bit. Hopefully nobody gets whiplash. Meshing TET elements on a round. These are kind of dodgy elements, and we wouldn't want those. So we can apply a face meshing to them now and onto these faces, and the patch conforming TET mesher will give us a much better quality TET mesh around there. Welds and shell elements. So there's more support for solid welds now. So if you're welding solid geometries to each other, we can create solid element welds. So previously, a lot of the development in the weld meshing has been around shell elements. So now we can use these weld meshing tools for solid elements. And there's a whole bunch of controls that allow us to auto-detect which faces we want to generate the welds between. So we can set this lap weld angle, and it will automatically detect, based on our angle that we specify, which faces are going to be included in the weld elements that get generated. And if you have a butt weld, you can switch on this butt weld option and it will automatically recognize that it's a butt weld. So that's with it off. You can see it's trying to create some weird weld here that shouldn't exist. If you switch it on, it goes, hang on, that's a butt weld, and it knows to create the weld elements through there. And also heat affected zones. So these are back to shell elements. We often want to model heat affected zones in weld meshes. Maybe to assign a different material property because it's annealed now, or just for different post-processing. Or we just want a better quality mesh around the join region in between the welds. So previously we would get a sort of a quad dominant messy mesh around here, and now we have this lovely mapped, very regular mesh in the heat affected zone. And you can create named selections of the heat affected zone elements for separate post-processing or material assignment. The prime mesh is the new meshing algorithm for shell elements, and it's undergoing lots of enhancements, basically to bring it up to speed with the old mesher, so it supports all the same features. So one of those is the automatic defeaturing of thin faces and edges. So you can see you can set some criteria and it'll automatically pinch out some of these regions and improve the mesh in general. Here's another region where we've set an angle to automatically pinch out some of these small elements. We can preview the quad mesh as well. So if we want to have a quick preview of the quad layer of elements that we have around holes, for example, for bolt attachment or spot welds, we can do a quick preview of the quad layer rather than having to generate the whole mesh and then make some changes and go back and remesh. It just speeds up the process. And it also supports body of influence and sphere of influence now. So that was a big shortcut coming of the prime mesh, the inability to do body of influence and sphere of influence. So as you can see, they're both supported. And pi prime mesh. So this is undergoing gradual enhancement as well. So pi prime mesh is the Python based meshing tool that allows you to do scripting of your meshing process. It's the Python is creeping into all aspects of the simulation setup now, and it's improving in the meshing area. So you can see here, as of 2024 R1 and 2, we're supporting more aspects of multi-zone mesh and lots of other features. So there's lots of APIs being added all the time. So if you're playing around with meshing in Python, you can get into all these new APIs.